Today's video will be the last video that we are going to go over before the test. So the test will be on sections 1.1 through 1.4, and that'll be on Wednesday. I'll go over more about this in class, but this will be the last lesson on the test. So today, 1.4, is on literal equations and formulas. So we've been dealing a lot with variables and equations with one variable and equations with two variables, and so now we're going to look at literal equations and formulas. So we're basically going to be applying what we've been talking about to more types of situations. So a literal equation is an equation expressed in letters or variables. Literal equations can use letters for both constants and variables. So essentially a literal equation is just an equation made up of constants, which is numbers, and variables, as well as, and it's not one variable, it could be x, it could be y, it could be z, it could be all three, all in one. So the first thing we're going to do is we're going to practice rearranging formulas or literal equations to solve for a specific variable out of all the variables we have. So in 14, we're given the literal equation k equals a minus y, and they're asking us to solve for a specific letter, and in this case, they want us to solve for y. So I'm going to quickly underline the variable we're solving for, okay? And I notice that I have a minus y on the right and just k on the left. So what I'm going to do is I want to use a positive number because I just want y. I don't want minus y, I want y. So I'm going to add y to both sides. And I get k plus y equals a. But I want to solve for y, so I'm going to then subtract k from both sides. So I get y by itself. So y equals a minus k. And that's my new literal equation. Let's look at another one. In 20, we're given the literal equation y equals 3 over 5u plus 5. Solve for u. So the first thing I'm going to do is I'm going to get a common denominator, which is 5u. And I'm going to multiply 5u to the top and bottom of 5. So I get y equals 3 over 5u plus 25u over 5u. I'm going to combine the numerators of the fractions on the right. So I get y equals 3 plus 25u over 5u. And then I'm going to multiply both sides by 5u. So now I have 5uy equals 3 plus 25u. I want everything with a u on the left side of the equal sign, everything without a u on the right side. So there are two items with u's, that's 5uy and 25u. So I'm going to subtract 25u from both sides. And I get 5uy minus 25u equals 3. I only want to solve for u, so I'm going to factor out a u from the 5uy and the 25u. So I get u times 5y minus 25 equals 3. And then I'm going to divide both sides by 5y minus 25 so that I can isolate the u. So I end up with u equals 3 over 5y minus 25. And that's my new literal equation. Let's look at a couple more examples. So in number 22, it says 12 times the quantity of m plus 3x equals 18 times the quantity of x minus 3m. And it says solve for m. So first thing I'm going to do is I'm going to distribute the 12 to both terms on the left. I'm going to distribute the 18 to both terms on the right. So this becomes 12m plus 36x equals 18x minus 54m. I'm going to get everything with an m on the left side and everything with an x on the right side. So I'm going to add 54m to both sides. So I end up with 66m plus 36x equals 18x. And then I'm going to subtract 36x from each side. So I only have an m term on the left-hand side. So I get 66m equals negative 18x. And I want to solve for m, so I'm going to divide both sides by 66. So we get m equals negative 18x over 66. I'm going to reduce this by 6 to numerator and denominator, so I get negative 3x equals over 11. And so m equals negative 3x over 11 is my new literal equation. The last one we're going to look at before we look at applications is 26, which says x equals 3 times the quantity of y minus b over m. And it asks us to solve for y. So the first thing I'm going to do is I'm going to multiply both sides by m so that I just don't have any fractions. So I get m times x equals 3 times the quantity of y minus b. I'm then going to divide both sides by 3 so that I am left with just the y minus b on the right. So I get mx over 3 equals y minus b. Then I want to solve for y, so I'm going to add b to both sides. So I end up with mx over 3 plus b equals y. And that's my new literal equation. So now let's talk about the usefulness of literal equations. For example, many of us have seen formulas in science, in math, so we've all heard about formulas. And the nice thing is that a formula is a kind of literal equation where one quantity is related to one or more other quantities. To solve for a particular variable in a literal equation, you rewrite the equations, isolating the variable. So when we are solving for a particular variable in a word problem, we're going to use a formula or a type of literal equation and use it to help us solve for our missing variable. So the first example we're going to look at, it says, according to Tio's bread recipe, he should bake the bread at 190 degrees Celsius for 30 minutes. His oven measures in Fahrenheit. To what temperature in degrees Fahrenheit should he set his oven? So the formula to convert Celsius to Fahrenheit is C equals 5/9 times the quantity of F minus 32. But we don't want to solve for C because right now it's C equals, so it's relating C to other quantities. Instead, we want it to solve for F. So the first thing we're going to do is rewrite our formula to solve for F, because that's what we want to do. So I'm going to first multiply both sides by 9, so I get 9c equals 5 times the quantity of f minus 32. I'm going to divide both sides by 5, so I get 9c over 5 equals f minus 32. And then I'm going to add 32 to both sides, so I get 9c over 5 plus 32 equals f. So to find the value of Fahrenheit compared to Celsius, I just plug it into this new formula. Okay, so for step 2, I want to know how many degrees in Fahrenheit it is if it's 190 degrees Celsius. So I'm going to take my new formula and plug in 190 degrees Celsius for C. So I have 9 times 190 over 5 plus 32 equals F. And when we simplify this, we end up with 374 degrees is equal to the value in Fahrenheit. So Tio should set his oven to 374 degrees Fahrenheit. The last problem we're going to look at says, William got scores of Q1, Q2, and Q3 on 3 quizzes. Write a formula for the average X of all 3 quizzes. William got an 85 and an 88 on the first 2 quizzes. What formula can William use to determine the score he needs on the 3rd quiz to get an average of 90? What score does he need? Okay, so the first thing we're going to do is we're going to write out a formula for average. So we know that average is equal to the sum of all the numbers divided by the total numbers. So average, it said, was X in the problem. So we're going to do X equals the sum of Q1, Q2, and Q3 divided by 3, because we have 3 quiz scores in total. So we're going to use this formula to find the average. So this is the formula from the beginning. We'll name that first step, step 1. Okay. Then it says for step 2 that Q1 is equal to 85 and Q2 is equal to 88. They want us to rewrite the formula we had in step 1 to solve for Q3. So solve for Q3. So the first thing I'm going to do is multiply both sides by 3. So I get 3x equals Q1 plus Q2 plus Q3. And then I'm going to subtract Q1 from each side. And then subtract Q2 from both sides. And so now I've solved for Q3. So the last thing it says is, what score does he need in order to get that average of 90? So we're going to plug in 90 for x in step 3. Okay, so in step 3, x is equal to 90, Q1, we already said earlier, was equal to 85, and Q2 is equal to 88. So I'm going to plug in those numbers respectively. So I get 3 times 90 minus 85 minus 88 is equal to the value of quiz 3. From here, I just simplify, so I get 270 minus 173 equals Q3. And when I subtract those two, I get a score of 97. So score that William needs is a 97. So that's the lesson. The classwork is due at the end of the class period on Friday. We will spend some time going over it in class on Friday as well. The page is 28 and the numbers are 9, 12, 13 to 27, odd, and 29. And I look forward to seeing all of you on Friday.